All right. Well, good morning, everyone. My name is Mike Booth. I'm the technical director at Inorganic Ventures. While we give a minute or so for people to file into the webinar here, I just want to go over a couple of just housekeeping rules for the webinar. We're going to be running a lab demo video here in a moment. But if you have any questions, please feel free to submit questions through the Q&A portion of the webinar tool here, and we'll be happy to answer them at the end of the video. It's pretty quick, about 13 minutes long, and then we'll be back live and answering your questions. Also, if you are interested in getting some samples of the discrete analyzer reagents, we're going to post a link in the chat where you can follow and complete a survey, and we will get samples sent out to you. So without further ado, it looks like we've got everyone pretty well in here. We're going to go ahead and start that video up. And again, if you have any questions, please let us know. Thank you. All right. Well, thank you all for joining us in the lab. Today, we're going to talk a little bit more about discrete analyzer reagents. I want to introduce everyone to Liv Forbes. She is our R&D chemist, and she is the main person working on the discrete analyzer project at Inorganic Ventures. So this is a pretty exciting project that we're going to talk a little bit more about the method chemistries. We're going to do some data workup. Liv is going to show you the process of actually setting up a run. But if you're not familiar with discrete analyzers, they are a really cool instrument. Basically what they do is they take a lot of the traditional wet chemistry techniques that chemists have honed over the years, and they take a way to sort of automate that, so you don't have to spend all your time doing that. And they can analyze samples very, very quickly. It's actually a really nice, fast tool that you'll see to get lots of samples run through, short amount of time, and very accurate results. So if you're not familiar with how they work, you'll have your sample. Your sample will react with reagents. Once that happens, they'll get held at the proper time and temperature in the instrument, and then some sort of color change should happen. So once that color change happens, the instrument's going to pick that sample back up and run it through basically a spectrometer. It's set to different wavelengths, so you can record the absorbances. And those absorbances will then, you'll calibrate based on a calibration curve. Then you'll read your absorbances of your unknowns against that, and it's a really quick tool. One of the biggest challenges that we had in this project is the stability. A lot of the methods that are out there, they list very short stability times. So I'm going to kick it over to Liv, and Liv, can you tell us a little bit about the stability work that went into this project?
Yes, so here at Inorganic Ventures, we are ISO 17034 accredited. So we already have a really robust stability program for all of our other products. But for the discrete analyzer reagents, we are testing them at room temperature and refrigerated for just until we get a failure. And we're testing them every 3 months on the discrete analyzer, and then we are analyzing the absorbances and making sure that our calibration curves are still good with those reagents. So let's go ahead and get a run set up.
Perfect, that sounds great.
Alright, so today we're going to be testing our silica method reagents. We have 2 methods for silica, and they're at their 3-month testing point right now. So I'll just kind of walk you through how to set up your run on the instrument. So the first thing you're going to want to do is whatever container you're putting your reagents in, you're going to want to label those and make sure that you're putting them in the right spot on the instrument once you fill them up. So I like to label mine with the method, the name of the reagent, and then also the location that it's supposed to be in our little tray. Depending on how your instrument's set up, that might not be useful for you, but that's just how I like to do it so I don't get myself confused. So then I'll just fill up the wedges, and then we'll put our sample holder on top, and then we can fill our sample cups as well. So I'm going to do that, and I'll be right back with you. So now that we've got our reagents poured up, we're going to put our sample tray on top. For your instrument, it might be a different setup, but you'll just fill up your reagents and then you'll fill up your samples, and whatever method you need to do for your instrument, go ahead and do that. So for our instrument, it will automatically dilute your high standard, so you don't have to manually make a calibration curve. So I'm only going to pour in our high standard and then our check solutions. But for you, if your instrument doesn't do that, or if you're running a method where you need to make a manual calibration, you'll probably have a lot more samples in your tray. So now I'm just going to fill up our sample cups with our sample and our standards. Depending on how you've set up your method, sometimes your standards might go in wedges under your thing, or whatever container you might put your reagents in. If you're running a lot of samples, you might need more standard because you might need to have a larger volume than the sample cups can hold. So now that we've got our samples poured, all we need to do is set up our run on the software, and then we can just hit go.
All right, well, thanks, Liv, for showing us that setup. That was super fast. So, like Liv said, we have the silica running now, but we want to talk a little bit more about the methods that we already have fully developed and launched. So we're going to start off with chloride.
So we currently sell one reagent for the chloride method based on EPA method 325.2. That reagent is comprised of two sub-solutions. There's a ferric nitrate solution and a mercuric thiocyanate solution. One benefit to the pre-made chloride reagent is the mercuric thiocyanate reagent or sub-solution that goes into making the reagent. If you're testing mercury in your lab as well, there's a chance that you could get mercury contamination into your glassware or anywhere in the lab, and that could skew your results for other analyses that you're trying to do along with chloride.
All right, so yeah, as Liv mentioned, this is our singular reagent for the chloride method. It comes in a 500 ml bottle. The chemistry for this method is actually pretty cool. So the free chloride in your sample is going to react with the mercury thiocyanate, the mercuric thiocyanate. And what's going to happen is the chloride is going to get bound to the mercury, and then that free thiocyanate is actually going to react with the iron present in the solution, and that's what's going to form that color change that you'll see. So it's actually a pretty neat little reaction, and it works out really well.
So next, let's talk about our sulfate reagent. The sulfate method is based off EPA 375.4. There's just one reagent for this method. Traditionally, most discrete analyzer methods are colorimetric, meaning that the reagent and the sample form a color change when they react. For the sulfate method, it's a turbidimetric reaction, so barium and sulfate form a suspension, and as that goes through the spectrometer, the suspension captures light, so there's not as much light going through, similar to how a color would.
All right, so yeah, one of the important things about the sulfate method, as Liv mentioned, it forms that suspension. That suspension is sort of held in place by gelatin, and one of the most important things that we found is you really want to qualify the gelatin that you're using. Just because they have the same CAS number does not mean the gelatins will work, from if you buy it from one vendor to the next vendor. So that's really important if you are making it up on your own. Or you can just buy one of our pre-made reagents and it's pre-qualified for you. So next we're going to talk about the phosphate method. We actually have two reagents for phosphate that follow EPA method 365.1, and Liv's going to tell us a little bit more about those reagents.
As Mike mentioned, there are two reagents for the phosphate method. There's the ascorbic acid reagent and also our color reagent, which is comprised of a couple different salts. The chemistry for this reaction is a little bit difficult, but we do have chemistry one-sheets available on each product page for the discrete analyzer reagents on our website.
All right, so last up we have our ammonia reagents. We have two reagents that follow ISO method 15923-1. So this method is, unlike the phosphate method that Liv mentioned, is a little bit more well understood. So essentially the DCI is going to undergo alkaline hydrolysis to form hypochlorite. That hypochlorite is going to react with your free ammonia to form chloramine. And then that chloramine is going to react with the salicylate to form the final endophenol, which is going to be the blue color that you see in that reaction. So it's a pretty good reaction overall. And again, having these reagents pre-made just makes your running your method all the easier. So last up, I'm going to kick it back over to Liv, and she's going to share any final tips she has for running Discrete Analyzer.
So I've been running the Discrete Analyzer for Inorganic Ventures here for about a year, and there are just a couple things that I've noticed help really ensure that your analyses will be really accurate and efficient, and you won't have as many problems. You won't have as much troubleshooting to do. It might sound really obvious, but one of the biggest things that helps is keeping up with the instrument maintenance. For ours, it's a syringe drive, and if that syringe goes bad, then your sample volumes aren't going to be accurate, your calibration curve's not going to be accurate. And there are also peristaltic pumps that live inside the instrument that, they pump water around, they pump the solutions around, and if those get crinkled from sitting in the instrument for too long, then again your volumes won't be accurate, and then what's the point of having the instrument dilute your things if it's not putting the right volumes into your samples. And then one other thing that really helps is keeping a good log of your water backgrounds every day, so that you can see if things are getting dirty, you can know to replace them, or if you get a weird result, you can look at your background and make sure that it's not something that could have been prevented and it's something with your sample or your reagents.
All right, thanks, Liv, for sharing those tips and tricks with us. And thank you guys for your time. Next up, we're going to cut away and do some data workup from the run that's been going on this whole time. So you'll see how our stability, our 3-month stability for silica is turning out. So we'll do some calibration curve workups and some absorbance checks. And I'll see you in a second. All right, so we're going to go ahead and start working up the data that was generated in the lab. Liv has gone ahead and sent this data over already. And so we're going to take a look at the raw data, work up a quick calibration curve, and double check that our absorbances are in range. All right, so you can see that this is the raw data from the instrument, and Liv has very wonderfully gone in and added these target concentrations that we were supposed to hit. And I have went ahead and added in the absorbance ranges that we anticipate. So we'll see how well we're doing on these. This product is still in development, so these ranges may get tweaked as we collect more stability data, but we're going to go ahead and get started generating a simple calibration curve. So this is something you guys have probably seen, a dozen times before. Pretty straightforward. We're going to put one in, a XY scatter plot in real quick, add a trend line and see what our R squared value looks like. R squared value is looking pretty good. So we've passed our calibration curve fit for this product, for this stability testing lot. So that's looking good. I'm just going to go ahead and set that off to the side down here. Next up, we're going to check to see if our absorbances are in range. So I'm just going to take our absorbance data from the first standard. We don't really include the blank on these checks. There's a little bit more variance, and we, as Liv sort of shown, she does a good job of checking the backgrounds on the instrument. So we're starting with our first low standard on this. I'm just going to copy this data down, paste it over here real quick, and then just do a simple check formula on it. See if we get a pass-fail on this data. So it should be real quick just to write the logic in to check it. So I want to make sure that our absorbance value is going to be, greater than or equal to our low range. And also make sure that it is less than or equal to our high range. And if that's true, we're going to call it a pass. And if that's false, we're going to call it a fail. And we'll see what happens here. I copy this down. Should have all passes, and just making sure that our formula copied correctly. So overall, things are looking good. The stability data is a overall pass. We'll do a little bit more. We'll end up doing a little bit more work on it just to see what our detection limits are, because we'll be tracking that as well through the stability study. But data, like I said, very easy to work up. The discrete analyzers, it's a very straightforward process. So now we're going to kick it over back to the live session, where we'll be happy to answer any of your questions. And I'll see you then. All right. Well, thanks everyone. Again, if you have any, we're starting to get some questions coming in now. But if you have any questions, please feel free to submit them through the Q&A box. Just a couple of follow-ups from that video. Again, I did want to mention, if you are interested in samples, please click the link that's in the chat, and that'll take you to a survey where you can get your samples. Also, if you are sort of looking over the product pages, we do have other resources that if you want to reach out to us, our team has developed a pricing tool that they can sort of work with you on, that will give you a good price comparison between purchasing the pre-made reagents and also the time that you spend making up reagents on your own. So if you're interested in that, please reach out to us. And also, if you need to update your SOPs or work instructions. We also have the resources available to help you out. If you need help updating your SOPs, we can do that as well. So please don't hesitate to reach out to us. We should be able to help you out with anything you might need. And with that, I'll go ahead and get into the questions. So first question up is from an anonymous attendee. It says, I've seen some mercury contamination issues that will come up with the chloride reagent we make in our lab. Are there tips for this? All right. So, Liv, any thoughts on mercury contamination issues?
I mean, besides, purchasing a pre-made reagent so you're not handling that starting material in your own lab, the only thing I can think is, just be as careful as possible with it. Make sure you wash all your glassware and any equipment that you're using in your lab really, really well. But we haven't really experienced a lot of contamination because we made the reagents once and then we're continuing to test them. So we don't have that starting material out and about a whole lot.
Yeah, that's one thing I'll sort of add on to that. Since we are a manufacturing facility, we have really tight specifications on, how things are made, the cleanliness of the work area and everything before a new batch gets made. So following those protocols really helps out. But if you're having issues with mercury contamination, in your lab, I would say please reach out to us and give us a little bit more details, maybe what type of instrument you're noticing the contamination on. We can help you with like washout solutions. We can send you our cleaning protocols, that sort of thing. So if you want more information, please don't hesitate to reach out. You can email, it should be info@inorganicventures, and just with a question, and one of us will see it and we'll be able to help you out. All right. Next question is, when will the ammonia reagent be available? Oh, this is a great question. So this is one we've gotten a lot of interest in. And we are finalizing the ammonia reagent to be complete. It should be available for sale tomorrow or next Monday. So if you're interested in those, let us know. That is one of the options. You can get a sample of that if you follow that survey, the link in the chat. So those are going on sale very, very quickly. We've just completed, the first lot has completed manufacturing. It just got bottled out the other day. So we're finalizing it through our, new stock product process. So once all the paperwork is signed off on, it'll be released for sale. So those will be very, very soon. All right. Next question is, I still use a flow analyzer. Can the reagents be used on this instrument? This is a really good question. So my understanding is that the chemistry for the flow analyzer and the discrete analyzers are very similar, if not the same. So I would say if you are interested in that, please reach out to us so we can sort of review the methods. This is a good time. If you have questions about what exactly are in the reagents, those chemistry one sheets that were shown during the video, you'll find those on the product landing pages for each of the reagents. Those will tell you exactly what's in the reagent, but if you need them tweaked slightly, please reach out to us and we can sort of work through that process with you. Also, I know a flow analyzer, a 500 ml bottle may or may not be enough. So if you're looking into larger volumes, also, again, just reach out to us. We have the ability to do that as well. The 500 ml bottle is just our stock bottle, but we do have the ability to do, larger volumes if that's required for a flow analyzer. All right. Next question. This person says, nitrite, you got a test kit as per hydrazine method and cadmium reduction method. And what is the shelf life before opening the bottle? Perfect. Yeah. So this is a great question. So we are working on both the hydrazine method and the cadmium reduction methods. Liv, do you want to give a little bit of an update as to where we are with those?
If you want to talk about shelf life, I'll get those dates.
Sure.
If that's okay.
Yeah, definitely. So yeah, I'll go ahead and jump into shelf life. So as of right now, all of the reagents that we have released, the chloride method, sulfate, phosphate, and ammonia, very soon to be ammonia methods, those all have 9-month shelf lives at the moment. Again, so as we mentioned in the video, the stability studies for these products are undergoing. So what we're doing is we're updating the C of A every 3 months as they complete their testing. So if they pass when it hits their 12-month point, we will update the C of A to say it will expire in 1 year from its point of manufacture. So that'll continue through the lifespan of the stability study, either until we see something that fails, or we see a deterioration in the detection limits over time that we would not feel comfortable, selling an older product. But I feel pretty confident that for most of these, based on the data that we're seeing through the stability study, I think they'll hit 1 year. We're just sort of waiting that through. So Liv, any news on the hydrazine and cadmium reduction?
So I just checked the timeline. The hydrazine reduction method, we had a little bit of trouble because that one was really pH sensitive. So and the materials used to make the reagents, so we kind of had to restart. So we've only got 3 months of stability data for the hydrazine as of a couple weeks ago. So in 3 more months, we'll test them again at 6 months, and then we'll be able to share those with you. And then the cadmium coil does have 6 months of data, so we just need to go through the process of getting them ready to sell and getting the whole product development portion ready for customers.
That's right. Yep. So I think that kind of answers the next question about when the nitrite reagents would be available. So like Liv said, we're a little bit faster on the cadmium reduction, but that again sort of has to go through our internal process. My first production batch has to be made, those sorts of things. So as we get closer to that, we'll start having the materials ready, like the chemistry one sheet, so you can download from our site. We'll have samples available for those as well. Actually, in that survey, if you are interested in other samples other than the ones we have prepared currently, you can mark those down as well. So we'll have that information as products become available. Yeah, so definitely on their way soon. Next question is, how long do the reagents last? And I'll kick that over to you, Liv.
So like we've mentioned, we've been doing stability studies on them. So the ones that we currently have available, chloride, phosphate, sulfate, and ammonia, they have 9 months of stability data that we've got available. And the stability studies are currently in progress. So as we get more data, we'll update, our C of As and update the customers and let them know, hey, you bought this, it's going to last longer than, it said when you bought it, because we have more data now. So it just depends on which reagent and when you buy it, because as we get more stability data, we will update the expiration for those.
Great. All right. So next question is, can the ammonia reagents be used with EPA method 350.1? So that's a very good question. That is something that you'll find more information about in the chemistry one sheets. But what I can tell you is they were developed using the concentrations listed for the ISO methods. But the EPA method 350.1 does use a very similar chemistry. So I would recommend just reviewing those chemistry one sheets. That'll tell you the exact concentrations for the 2 reagents that we have for the ammonia method. And if you have any questions, once you reviewed that, please feel free to reach out. But it is a very similar method. So I think that, maybe some tweaks to the volumes, and I think it would work out for you. But again, I would refer you back to the chemistry one sheet so you know exactly what's in the bottle. All right. Next question is, what is the shelf life of the chloride reagent once opened?
I can do this one if that's okay.
Yeah.
So for chloride, once you open it, our expirations for these are really based on the chemical stability, not so much like with our other products. If you're familiar, we use TCT to keep them from transpiring before you open them. With these, our expirations are really based on the chemical stability. So unopened or opened, it'll still be stable for, however much we said. So right now, chloride is 9 months. I've been through the stability testing, I've been using the same bottles. So at least in my experience, opening and reopening doesn't seem to have an effect as long as you keep them in the correct storage conditions.
Right. All right. let's see. It looks like we are, if you're experiencing any issues on the chat, please let us know. You can just submit a question through the Q&A. But it looks like we might be having some issues there, but I will go ahead and move on to the next question. And that is, when will the nitrate reagent for the enzyme reduction be available? So this is something that we haven't started. This seems to be a method that is not done as frequently as the hydrazine or the cadmium reduction. There's also another type of reduction method out there for nitrite. So those we're looking into as well. I don't have a timeline on those yet, but if you are interested, keep an eye peeled on our website. We'll be launching these honestly, probably throughout the next 12 to 18 months. So there's a lot of them going on. So if you are interested in that one specifically, you can also reach out to us and we can get in contact with you and just sort of follow up on your needs and see what we can't do in the meantime. But those are something that we have sort of charted out, just they're not, because of the popularity, they're not higher up on the list. So if we see a lot more people that want them, we can definitely bump that up. All right, next question is says, from the presentation, it sounds like these are relatively new products to the market. Have you done a stability test with the ascorbic acid reagent for the phosphate? In our lab, we prepare this reagent on a weekly basis because of the stability, and I believe you're proposing a 9-month shelf life. Do you think the 9-month shelf life is realistic?
Yes, so we've been doing stability studies on the phosphate reagents, the ascorbic acid, and the other one. And we have noticed a color change in the room temperature one. But the refrigerated, if you keep it refrigerated, it seems to be just fine over 9 months so far.
Yeah, that's an excellent point, Liv. We've been doing the stability studies. I think Liv mentioned it in the video, but we're doing both room temperature and refrigerated. So right now on the C of A, we recommend storing everything refrigerated. As we come up on that first 12 months of stability, we're going to take a look at the data and reassess some of those storage conditions because we know that some people would prefer to keep them at room temperature. So we're really going to take a hard look at it and see about those storage conditions once we have at least 1 year's worth of data. But the ascorbic is something we've heard pretty frequently that people are shocked that it's able to be stable for that long. I'm not sure. It may be the ascorbic we're using or our water source or our bottles with refrigeration. But we have seen that it is stable for that long, and that has been one of the more surprising ones to the users of discrete analyzers. All right, we'll go ahead and work on the next question here. It says, I usually work with phosphates that employ the Olsen's method in order to detect it, but ammonia salts seem to be an interference. Is there a recommendation for that? Is it solved with our phosphorus kit? So I'll give a sort of a little bit of background on this as well. We are looking at more into interferences. We actually have a side project for the reagents that is more based around like what interferences can really have an impact on calibration curves. Basically, if you're familiar with inorganic ventures, you know that calibration standards are our bread and butter. So we're trying to design some calibration standards for discrete analyzers that could have multiple analytes. So we're really taking a good look at the interferences on each method to see how it's going to impact it and if we can make any changes to make those better. So I don't have a good answer, Irene, for you at the moment. I would just say, again, the chemistry 1 sheets, they reference the standard and the EPA methods for all of our products. So I would say we could go through that and see if it lists ammonia as an interference. But yeah, I just don't have a better answer to that right now, but we are working on it. All right. Next question. It says, can the phosphate color reagent also be used for total phosphorus? This is a good question. So it depends on what you mean by total phosphorus, but we do know that a lot of people report phosphate as just phosphorus. So again, I think the phosphate method is a little strange. We'll have the references on the chemistry 1 sheet. That method is, the chemistry for it is a little, it's not exactly well understood. I mean, it is well understood, but they don't have the exact, you know, reactions worked out, at least not from what we can find. So I would say if you're just reporting it as phosphorus, we have seen that, and that's very common. So I would think that would work. If it's a different type of phosphate, like a pyrophosphate or something like that, I'm gonna have to refer back to the paper that we found that sort of goes through that chemistry, and get back to you on that. So if you're just reporting it as phosphorus, I would say yes. But if you actually mean like a different type of phosphate, then we would want to do a little bit more research. And if you have any more details on that, please feel free to contact us and let us know. Next question. It says, are you developing reagents for cyanide? And Liv, I'll kick that over to you.
So we actually just started looking into this. So our processes are, we look at the method, then we look at the safety of the starting materials, then we order them and we make the reagents and we start testing them. So we've currently just finished our safety assessment of the starting materials. So I will be ordering them soon and getting that stability study started as soon as I can for cyanide reagents.
Great. All right. Next question. Are reagents made according to seal SOPs? So this is a great question. So they can be and they may not be. So we're making our reagents to the, I would say, for lack of a better word, the recipe that you find in the EPA or the ISO method or the standard method. Sometimes that overlaps with what, like SEAL recommends as their SOP, and sometimes it's slightly different. So again, the chemistry one sheets will tell you exactly what is in each reagent. So you can refer that if you're running a SEAL instrument to the SEAL SOP they have, and you'll see that either they may be the same if SEAL is using the same method chemistry as the standard method or EPA method, or they might be slightly tweaked. I haven't come across any yet that are like completely different. It's usually just like different concentrations, those sorts of things. All right. Next question is, how sensitive are the reagents to temperature shipment in hot countries that may deteriorate them? Is hot temp part of your stability studies? That is a great question. Liv, I will kick that over to you.
So yes, as a part of 17034 for our regular products, we do transport stability. So we're doing that for these as well. So we haven't finished that testing, but it looks like for the 4 that we've got out, phosphate, sulfate, chloride, and ammonia, the only one that looks like it might be a little iffy is ammonia. The rest of them look really good. So feeling good about it.
Yeah, and that's something that we sort of go through, and with each new product, it's sort of one of those things. We have to test the shipping conditions. We call it transport stability. So it's a factor that's taken into account before each new product is released. So yeah, we're undergoing reviews for those, and that testing is done for each new product. So I think you should be safe. But if you ever run into an issue, again, just reach out to us. We'll be happy to try to solve any problem you got. All right. Looks like we have the last question here. It says, we are working with the scalar discrete analyzer. Do the reagents comply with the methods that are available from them? So that's a good question. Again, I would refer back to the chemistry one sheets, because that'll tell you exactly what's in each reagent. If you have any concerns, I would say please reach out to us. I don't have the scalar methods in front of me, but again, from what I've seen, everything, all the discrete analyzers they use, if they run a chloride method, it's a pretty close variation to the same method that runs across any other discrete analyzer instrument. The manufacturers might recommend slight tweaks to how the reagent is made, but they also will probably offer slight tweaks on how much of the reagent versus how much of your sample is made. That seems to be the bigger sort of change from one instrument manufacturer to the other. Not so much the reagent, but just essentially how much of the reagent, how much of your sample. So that's what I would be more concerned about. But again, I would just refer back to the chemistry one sheet, and that should answer your questions. But if not, please feel free to reach out to us, info@inorganicventures. and they'll make sure that that gets to the right person, and we can review your question and get back to you in a timely response. All right, so I think that is the end of the questions, unless I'm going to take a look at the chat here. Sometimes questions get filtered into there, but it looks like in the chat we just have links. So again, I would highly recommend those links to the chemistry one sheets, and again to the survey if you would like a sample. And I really want to thank you all for your time. If you have any questions, again, please follow up with us, info@Inorganic Ventures. And I hope you all have a great day. Thank you.
Thank you, guys.